Hi, my name is Andrew Stevenson, and this is my class assignment 2. So the first thing I did was I went on to the website and found a data set for classification. And so I found this thoracic surgery data set, which is data on lung cancer and different patients who've had tumors removed for that. And so the first thing I had to do was it's an ARFF file, which uh, R doesn't have a standard function for reading that, so I had to use this foreign library to read that. The second thing I did was just to make sure there was no missing data, I used the NA function just to check to see if there was any missing data, and there wasn't. Just looking at the dimensions of the data, there was 470 records using with 17 attributes, and then the column names were these, and so those are a little bit confusing. They're codes, so I went back to the website and just grabbed just to see what those actually mean. And so like DGN would be the original diagnosis for the patient, and some others in there, pre-7 as pain before surgery. And you can see the different, in parentheses, the different options for those. So some of them are true or false, and some of them have other values associated with them. There's numeric. This performance status had 3 different levels, etc. And the last value or attribute was the risk after 1 year. So basically this data is used to predict whether the patient is going to survive or not after surgery, getting a tumor removed. So the value would be true if they died and false if they lived. So to start off, trying to use this to predict that survival, I set the random seed to 1989, and I wanted to start off by splitting the data set into a training data set and a prediction data set. So I took 70% of the data and put it into a training data set, and the other 30% into a prediction data set. And then I used the table function just to verify that that split was done correctly, and it was. So the first decision tree library that I used was the party package, and so I loaded that, and then I created my formula to try to predict the risks after 1 year using all the different attributes, and created my tree using the ctree function and the training data set. And then I printed that decision tree, and as you can see, it only used the diagnosis attribute for the predictions. So then I went on and plotted that, and as you can see, the plot again shows just using the diagnosis attribute. And I know this is a little bit hard to read, but so false, meaning they lived, was for diagnosis 1, 2, 3, 4, and 6, and death, the true value was for diagnosis 5 and 8. Then I plotted that again using the simple type just to make it a little more clean. It shows the different probabilities for that. And in order to test that, I use test the prediction. I use the predict function with the tree and initially the training data set. And as you can see, it correctly classified 275 false values and correctly classified 8 true values, but there are also some missed classifications in here as well. Then I went on and to test the prediction with the prediction data set that I created. And so I created a table again, used the predict function and put that into a table. And again, there was a lot of correct for false, but also some misses. And then this one actually didn't even correctly classify any of the true results. So I think both of the models I used throughout this thing had trouble identifying when they actually died the true value after 1 year. So then I wanted to investigate a little bit more of the accuracy of the model. So I found this caret package, which has a confusion matrix function that gives you different values such as the accuracy, the 95% confidence interval, and all these other different values, sensitivity, specificity. And so the result of that showed that this model was 81.12% accurate, which I'm not an expert at this stuff, but I don't think that doesn't seem very good. So the second decision tree package I used was the rpart package, and so I did the same thing with my formula. I used the rpart function with a training data set and a complexity parameter of 0.02, which means that it would split the decision tree if the error was reduced by 0.02 within the model. And so then I printed that decision tree, and as you can see, it has a lot more splits than the other ones. I used the diagnosis, pre-4, pre-14, age, and age. So after plotting that, you can see I used the rpart.plot package, and I plotted that. You can see all the different splits, and so it used the diagnosis, the force vital capacity, which is pre-4, the size of the original tumor, pre-14, and just the age value. I Google searched how to plot decision trees and make it look a little better. So I found this library called Rattle, which has a function called fancy rpart plot, and so I plotted the decision tree again using that. You can see that there, and then again went through and tested the prediction with the training data set. Again, there were some misses, but a lot correct too for this model, just like the previous model. And then using the prediction data set, I did the predict function again, and again this one had trouble identifying the true value. It only correctly identified one of them. And then using the caret package, I did the confusion matrix function again to determine what the accuracy of this particular model was, and it showed up as 78.32%, which again doesn't seem very good to me. So the last thing I did was just went back and just to compare the different trees, and so both of them had similar accuracy, but the first one was slightly better with the 81.12% accuracy versus the 78.32. For the number of splits, the models were very different, with the first model only splitting one time, and then the second model splitting 6 times. But that's sort of interesting because the first model is actually more accurate using only 1 split. You intuitively would think that 6 splits would give you more accuracy as far as the prediction. So then just picking the best, obviously, since the first one had lower number of splits and higher accuracy, so lower error, then the first model to me seems to be the best. So that's it. Thank you.